Hello, good morning or good afternoon everyone, depending on where you are joining us from, and welcome to today's webinar. My name is Chance Millits-Bangs from Business Review Webinars, and I'm going to be your host for today's session. It is our pleasure to have VTT with us today, who will be discussing cellulose nanofibrils, a big hype or on the edge of a breakthrough. Today's guest speakers are Dr. Heli Kangas, Senior Scientist, and Pia Kvintus, Head of the Research Area. I'd like to welcome you to our webinar platform On24. You'll notice this webinar is browser-based, so if you disconnect at any point, please click on the link you received via email to rejoin the session. All of the icons along the bottom of your screen are the interactive widgets that we have on offer today, so please interact with them all as the session progresses. You can ask any questions at any point throughout this session using the Q&A widget or by using the questions box, and we'll try and get through as many of your questions as we can after the presentation has finished. You can also tweet about this webinar through the use of the Twitter widget using the hashtag nanoCellulose and hashtag CNF. You can also contact VTT directly using the purple Contact Us widget, and you can also leave any feedback you have on today's session using the red Survey widget. Before I hand over, just please use the Help widget if you experience any technical difficulties or require any more assistance as the session progresses. So, without further ado, please allow me to hand you over to Pia. Pia, over to you.
Thank you, Chance. Hello, everybody. This is Pia Kvintus from VTT speaking. First of all, I want to thank you all who are present here today. It is a great pleasure for VTT to have about 500 registered persons in our webinar. Thank you. So, at the beginning of my presentation, I will say a few words about the company. VTT, Technical Research Center of Finland, is the largest research organization in the Nordic countries. We provide expertise for our domestic and international customers and partners in private and public sectors. At VTT, our focus is in applied research. We act together with universities and industry. Our annual turnover is about 280 million euros, and we are about 2,600 experts working at VTT. The specific feature of our activities is that we do a lot of experimental research, and we also develop our unique research and testing infrastructures. We are widely nationally and internationally networked. As many of you may know, nanocellulose does not mean only one clearly defined type of material. The word nanocellulose covers a wide selection of cellulosic materials from nanocrystals to bacterial cellulose and various grades of fibrillated fibers. At VTT, we focus on research and development of fibrillated grades and use of the materials produced in various applications. Next, I will present you a short view to estimated markets of nanocellulose. There are a few published reports which estimate the potential markets of key applications for cellulose nanofibrils. Use of CNF in paper and board applications is seen as the most promising and fastest growing application. Besides the use of CNF in paper and board, VTT believes that other quite fast growing applications could be in packaging materials like composites and films, paints and coatings, oil and gas, cement, and food and cosmetics. As you can see, the estimated market volumes for different nanocellulose applications vary a lot, but also the market prices for different CNF grades produced can vary remarkably. In most of the reports published, the stage of commercialization for most applications is estimated to be between proof of concept and demonstration. Anyhow, some companies have already published use of CNF in their products in the areas of paper and board, healthcare, nonwovens, composites, and food. For instance, Imerys company published already at least 1 year ago a product called fibrillation, a composite filler made of microfibrillated cellulose and mineral. It can be used to create savings in fiber use in paper production. This is a good example of use of microfibrillated cellulose in a traditional production process for better competitiveness of existing products. Then another example of development of a totally new product is published by Nippon Paper. Nippon Paper just in April published a production of functionalized sheets made of Tempo CNF for healthcare purposes. This product called Acti and Poise can be used, for instance, for antimicrobial or deodorant applications. Development of production process of cellulose nanofibrils has been an issue of interest globally for a few years. Besides VTT, there are several companies in Europe which have published their production of cellulose nanofibrils. Most of these companies describe their process as pilot or pre-commercial process. In US, there are not yet too many companies in the field because the main focus in US has been in development of cellulose nanocrystals. In Japan, there are several companies acting already in commercial scale. In general, it can be said that the needs of local industry and application markets direct the development of production process and the CNF quality produced. Then to production estimates. As we can see, the estimates vary a lot depending on who is doing the forecast. It is estimated that by 2025, the use of cellulose nanofibrils can vary from 10,000 tons per year to 400,000 tons per year. The largest estimate is based on hypothesis that there would be 10 paper machines using CNF with a loading of 3% in paper production. Anyhow, we at VTT believe that a significant increase in production of CNF will happen in the near future. From this slide, I will turn to Heli Kangas, who will continue.
Thank you, Pia, and welcome to the webinar on my behalf also. So, in addition to market reports and analyses, patents and publications landscape offer a tool to look at the innovation activities in various fields. I will now show you a short video on what kind of information you can extract from this research landscape.
Welcome to view the patent and innovations landscape. For us at VTT, this is a tool to look at the patents and other publications related to nanocellulose. With the innovation landscape, we can see, for instance, the publication year trends, the field of applications, the key organizations patenting. For example, here the Finnish University, Aalto University, and the Japanese universities Kyoto and University Tokyo are among the top patenters, and we have had the pleasure of closely cooperating with them in our research. And also we can take a closer look at the patenting countries. China is currently the top patenting country in the world, with closely followed by Japan and the USA. And the documents, both the patents and the other publications, are mapped in the research landscape. And similar documents are gathered in the clusters in this map. And the similarity is decided on how many similar terms are used in the documents mapped. And the two words next to each cluster show the most frequent words in the documents. The closer the two clusters are, or documents are, the more similar the contents of them are. And the colors indicate the size of the cluster. The redder the color, the bigger the cluster is. If you want to look at the trends in patents and publications, we can simply select a number of years, for instance from 2000 to 2005, and see the map where the publications are related to. And if we want to take a closer look, we can look at the labels or the application fields and see that between 2000 and 2005 most of the publications are related to composites, film, strength, and so forth. If we then want to look at the most recent publications and compare them to the older publications, we simply map them on research landscape also, and see that more publications have emerged, and also quite new application fields have emerged also. For instance, food, emulsions, packaging, and rheology. The most recent publications from 2011 to 2015 are mapped here, and we can see also that the number of patents have increased tremendously, and all the most kind of common application field are strengthened here. For example, there are a lot of publications related to films, paper and paperboard, food already, that has increased since during the recent years, barrier, and rheology. And these are the kind of applications that we at VTT believe are the very strong ones. And but you can see that the application fields are quite scattered. At VTT, as a multi-technological organization with cross-sectoral competence, can address these applications.
In the video I just showed you, VTT's own patents and publications were left unmentioned. However, we are naturally active in patenting and publishing, currently holding around 45 patents and 60 peer-reviewed publications related to nanocellulose, and the total number of publications is around 100. The innovation landscapes just shown in the video are available not only to us at VTT, but for our customers also. With the help of our qualified information analysis team, you can take a full advantage of the landscape, enabling you, for example, to clarify your business opportunities and to find customers and partners interested in the same applications as you. This way, the path to becoming a market forerunner is more straightforward. I will now show you some selected cases on how we at VTT have used the scientific excellence for the generation of technological breakthroughs. At VTT, we have worked with cellulose nanomaterials since 2008, and during that time we have used over more than 40 different raw materials, produced and analyzed over 2,000 samples of cellulose nanofibrils, and worked together with over 40 different partners and customers. And since 2008, the total value of our research project has been 53 million euros. As already mentioned previously, VTT has a lot of cooperation with various instances from both industry and academia. Our solid scientific background stems not only from our own research, but also from the cooperation we have with universities and research centers all over the world. One example of our international cooperation is Professor Akira Isokai from University of Tokyo, who, together with his colleagues, is the 2015 Marcus Wallenberg Prize winner, and with whom we have had fruitful cooperation in many subjects related to cellulose nanofibrils, as well as research exchange between Finland and Japan. This slide illustrates selected topics related to cellulose nanofibrils we have addressed since 2008 at VTT. Rough indications of the development timeline are given by the arrows, and the gradient in the arrows marks the point where the research has progressed from the purely scientific work into application-oriented research together with the customers. In the following slides, I will present case studies related to cellulose nanofibril manufacturing and the following applications: cellulose nanofibrils in paper and board, CNF films, and CNF as the rheology modifier. I will also discuss the current status of each of the research areas and where we stand in regard to commercialization. The subject under discussion will be highlighted with green color. First you will hear about cellulose nanofibril manufacturing and especially possibilities for scale-up. In the chart shown in this slide, different methods to produce cellulose nanofibrils are mapped in relation to the fibrillation potential shown in the horizontal axis and to the production cost in the vertical axis. As you can see in the upper right-hand corner, the production methods resulting in more finer structure usually result also in the higher production cost, whereas by producing coarse grades with lower fibrillation degree, you can save on production costs, as is in the lower left-hand corner. Over the years, we have gained experience in numerous cellulose nanofibril manufacturing methods and have come to the conclusion that the method of production should always be selected based on the application requirements. For example, refining is a good method for producing coarse grades to be used, for example, in paper and board. Finer grades produced by chemical pretreatment and high-pressure homogenization can be used in low-volume, high-value applications, such as in types of transparent film. Enzymatically assisted production methods provide a good all-purpose cellulose fibrils, as the fibrillation degree can be adjusted according to your needs. At VTT, we have experience in taking cellulose nanofibril production from lab to pilot scale and also to pre-commercial or commercial production together with our customers. In 2011, two Finnish pulp and paper companies announced the start of pre-commercial production of fibril cellulose. VTT was involved in the development of the production methods with both of these companies. To our knowledge, the companies are ready to start commercial production as soon as there is sufficient demand for the materials in the applications market. The high energy consumption of cellulose nanofibril manufacturing often presents a challenge for the industrial manufacturing. Therefore, it is my pleasure to to introduce you to the VTT's HefCel concept, which is our unique solution towards production of cellulose nanofibrils with lower energy consumption and thus enabling reduced costs. In the HefCel method, the raw material is treated at high consistency with specific cellulose enzymes resulting in fibrillation. In the figure on the left-hand side, you can see the type of equipment we are using for this technology. The machine resembles a kneading machine typically used in the food industry, and the mechanical action it provides to the material is quite different compared to the more traditional methods. The figure on the right-hand side is a scanning electron microscope image of the HefCel cellulose nanofibrils. The scale bar visible in the bottom of the image is 100 nanometers, and the image then shows that we are truly ending up with cellulose fibrils with width on the nanometer scale. And in a HefCel, there is no separate enzymatic treatment stage, but the fibrillation takes place due to the combined effects of the cellulose enzyme and the mechanical action. And after the fibrillation stage, the enzyme is inactivated by steam. The material is washed and the filtrate containing cellulose is recovered. The cellulose is a valuable byproduct of the process and it can be utilized, for example, by the chemical industry. After dewatering, the resulting fibrillated material is at high consistency between 20 to 40, which is a remarkable increase compared to the concentration of cellulose nanofibrils suspensions obtained from traditional processing methods, with around 2%. The benefits of HefCel fibrillation technology include the very low energy consumption, which we have calculated to be around €1 per ton. The method can produce CNF materials with variable fibrillation degree, as this can be tuned by the treatment time and enzyme concentration. In the optical microscope images shown in the bottom of this slide, you can see how the size of the cellulose fibrils is reduced with prolonged treatment time when moving from 3 hours to 5 hours and 10 to 9 hours. HefCel cellulose nanofibrils have potential in many applications, and the performance will be tested together with interested companies. In 2016, VTT will launch a project on upscaling of HefCel technology, and we are currently looking for partners to join the project. In the following section, I will address the usage of cellulose nanofibrils and in paper and paperboard. First, we will show you a short video of VTT's research environment for paper and board, in which trials with cellulose nanofibrils can be performed in the relevant context. The common fear in using cellulose nanofibrils in paper and board making are the problems in dewatering. However, our pilot-scale trials, together with the customer, have shown that although the dewatering can be reduced in the wire section, after the press section, the solid content can actually be higher when cellulose nanofibrils are applied. Both tensile strength and the elastic modulus have increased with CNF addition, thus enabling reduction in the basis weight. The graph in this slide shows development of tensile strength of paperweight as a function of basis weight. The reference trial points are marked with blue, and the trial points in which cellulose nanofibrils have been added with red and green. With the CNF addition, it was possible to reduce the basis weight by 8 grams per square meter while maintaining the tensile strength at the previous level. In our pilot environment, we have also tools to monitor the retention and distribution of cellulose nanofibrils in the web. Next, I will present you some research examples on the cellulose nanofibril films. Cellulose nanomaterials have an inherent tendency to form films upon drying. CNF films as such have been found to be very good oxygen barriers. However, as hydrophilic, meaning water-loving materials, they are sensitive towards moisture and water, which naturally limits their applicability, for example, as packaging materials. At VTT, we have taken different approaches to tackle the challenge of moisture sensitivity of CNF containing films. Firstly, we have created multi-layer films containing CNF as the middle layer and acting as the oxygen barrier. The electron microscope image in the upper right-hand corner reveals the structure of this film and shows that the thin CNF layer is wedged between the two polyethylene layers. The thickness of the CNF layer is only a few micrometers. When using bio-based polyethylene as the outer layers, we have obtained heat sealability and moisture barrier for the transparent film structure, enabling the use of film for packaging of dry foods, such as nuts. Typically, cellulose nanofibril films are highly unstable in water. However, with a very small addition of polyvinyl alcohol to chemically modified cellulose nanofibrils, films that sustain their structure in water for days or even weeks can be prepared. At VTT, we have brought the manufacturing of cellulose nanofibril film one step closer to industrial manufacturing by developing a method for manufacturing at semi-pilot scale using a surface treatment concept. In the future, we consider that the potential application of CNF films can be found in packaging applications, sensors and membranes, and in printed electronics, where the smooth and dense CNF films offer a cost-efficient and biodegradable alternative to plastic. At VTT, we have studied the phenomena behind the behavior of cellulose nanofibrils in water and various solvents since 2008. In addition, studies of CNF as the rheology modifier together with the customers in selected applications have been performed, and this work will continue as new application fields emerge. A relatively new research area are the CNF filaments and yarns, the study of which is also enabled by the deep scientific understanding of the rheological behavior of CNF suspensions. The rheological properties of cellulose nanofibrils are truly unique as they form gels at low consistencies and exhibit shear thinning behavior when stress is applied to the suspensions. As an example of the importance on profound understanding of the rheological properties, it has been found that the rheological behavior of CNF gels are dependent on both of the CNF grade and their concentration, both of which need to be optimized with application testing. The graph on the right shows that yield stress of the CNF suspensions is already apparent at consistencies as low as 0.1%, and the yield increases exponentially with increased consistency. In the graph on the left-hand side, the shear viscosity of different CNF grades as a function of concentration can be seen. The behavior of different grades is quite similar. In other words, fast increase is observed in the viscosity as the concentration increases before leveling off, but the level of viscosity between grades is different. The unique rheological properties of CNF gels make them potential rheology modifiers and emulsion stabilizers in many applications. Due to their wide process performance range, they can be applied in different formulations for emulsions, dispersions, gels, and foams, and in addition, offer novel materials for rheology development and testing. Benefits of cellulose nanofibrils also include nutritive nutritional value and biocompatibility. At VTT, we believe that most potential applications for cellulose nanofibrils as rheology and stability modifier include food and pharma, cosmetics, oil and gas, as well as paint and cement industry applications. As a multi-technological research center, VTT can offer application-related tailored solutions for the utilization of CNFs in these applications. We have also pilot-scale flow behavior testing and process verification to address these issues. CNF filaments and yarns can be prepared without dissolution and regeneration, which is a typical, for example, in the traditional viscose process. This can be accomplished by swelling the cellulose nanofibrils in solution and producing filaments by extrusion. As shown in the graph, with tensile index mapped against tensile strain, the produced filaments have very good mechanical properties. After going through the selected VTT research examples, I would like to share with you how we at VTT see the road ahead and how can we influence the market entry of cellulose nanofibrils and CNF-based products. First of all, we believe that cellulose nanofibrils are on the verge of a breakthrough. However, some applications are more likely to enter the market sooner, and some are still quite far from the actual commercialization. Here I must also emphasize that we do not see cellulose nanofibril as a miracle maker, which you can just apply to your product and enter the market. Succeeding needs a lot of hard work and resource investment. As Pia presented in the beginning of this webinar, there are already CNF-based products on the market, and as our innovation landscape shows, new higher value applications are emerging at accelerated pace. Previously, the availability of cellulose nanofibrils has been a problem since the interested companies have had no access to the material, especially at larger quantities. However, we believe that the production volumes will increase and availability will no longer limit the product development. Scientific excellence can help to overcome the challenges and bottlenecks in CNF product development. And I have two examples of this. Firstly, the high consistency enzymatic fibrillation concept developed is based on our knowledge on enzyme technology. And secondly, the upscaling of manufacturing of CNF films. It has been enabled by our understanding and tailoring of the surface chemical phenomena. And we at VTT believe that cooperation is a key to success. The combination of scientific excellence, market awareness, and testing infrastructure provided by VTT and the industry's knowledge of the market, business environment, and their own applications will accelerate the market entry of CNF-based products. So the key is partnering for success. Cellulose micro and nanofibrils have a huge potential in several applications, and for us the most potential are those related to paper and board, packaging, composites, films, oil and gas, paint, cement, food, pharma, and cosmetics. The major challenge is the cost competitiveness of the CNF-based products. In each of the application sectors, there are a lot of different alternatives available, and these applications differ in their industrial feasibility. So we need to be certain where to put our efforts. It's also worth remembering that there are different needs in the different markets globally. The key to success is a seamless cooperation, which requires a good understanding of the market needs, information you can obtain with business and innovation landscape, knowledge on raw materials, and also the scientific excellence as a background and combined with fast piloting. VTT partners with innovative companies to help in commercialization of CNFs. And together we can adopt a value chain approach and cover the whole value chain from raw materials to applications. So the key learnings from this webinar. There are both cellulose nanofibrils as well as products based on them already on the market, and new applications are emerging fast. High quantity enzymatic fibrillation, we believe, is a breakthrough for certain applications, enabling reduction in energy consumption and reduced costs. CNFs have a great potential as strength additives in multi-layer films and membranes and as rheology modifiers. And we should also always have the application in mind when planning the production, as the suitable production method depends on the application requirements. After this, I believe that it's time for the poll questions. Right, Chance?
Yes, that's correct. So thank you very much. And we're now going to move on to today's 2 polling questions. So this is to try and make the session more interactive for everyone. So if you want to answer this question, so what is the most relevant driver for you when introducing cellulose nanofibrils into your business? So if you can pick the option here most relevant to you and press submit to log your response, and we'll go through some results shortly. So your options here are from cost reduction, material savings, replacement of oil-based materials, environmental benefits, improved properties, or the branding or green label. So just while you're voting in that, I'd just like to remind you that you can tweet about the webinar through the Twitter widget using the hashtag nanocellulose and hashtag CNF. And there's also the purple Contact Us widget there for you to contact VTT directly if you wish to do so. And a reminder as well that there's the survey for feedback on this session located in the red survey widget, and we would appreciate it if you took some time to fill that out before you leave us today. Okay, so I believe that's enough time to have that first poll question there. So let's move on to our second one. So our second question for you today is, in your opinion, what is the most promising application for cellulose nanofibrils? So there's quite a few options here. There's paper, excipients, paperboard and packaging materials, paints and coatings, textiles, oil and gas, composites, non-wovens, cement, food and cosmetics. So again, if you can pick the option most relevant to you and press submit. Okay, so while you're voting in this poll, we have had quite a few requests in for the presentation today. I'd just like to inform you all that you'll be able to download the presentation as a PDF file from the on-demand version of this webinar. You'll receive an email shortly following the session, around 2 hours after, when the on-demand version is available, and then you'll be able to log back in and download the copy of the presentation. Okay, so with all that being said and done, let's move on and discuss some results. So firstly, the results from the first poll. Okay, so it appears that over half of the respondents there believe that improved properties is the most relevant driver. So what do both of you as speakers make of this? Is this the kind of results you were expecting?
Yes, yeah, this is a very good result related because we can truly improve the properties with CNF. So I was hoping and expecting this kind of answer.
Yes, I agree with my colleague.
Okay, perfect. So let's move on now and discuss the results from the second poll. Okay, so these are a bit more widespread, but it seems that the main driver there is paperboard and packaging materials. Again, is this what you were expecting, or was you expecting something slightly different there?
I would say that this is quite near the view that we had about the future applications.
Yeah, I would say the same. This is one of the largest kind of sectors that we are expecting also.
Okay, excellent. So when you're ready, let's move on to discuss where everyone can meet you this year.
Yes. So this is a list of where someone from VTT, researchers on cellulose nanofibrils, will be available to meet us. So in June we will be in Córdoba, Spain, and then we'll be attending a TAPPI Nanotechnology conference in June in Atlanta. And in September we'll be in Germany in the PTF Coating Symposium, and in October in Finland in this Nordic Wood Biorefinery Conference. And those participating from Japan, we are also planning on coming to Tokyo Paper 2015 in October, late October. So if you are attending these conferences, please contact us beforehand to set up a meeting, or you can just, if you meet us in these places, you can just grab our arm and ask your questions or wish for a discussion. And also, I think now then we are ready also for the Q&A session.
Okay, excellent. So in that case, we're going to move into our Q&A portion of today's session. We've had a lot of questions in, and we'll try and get through as many of them as we can. But if we don't get through all of the questions in this next 15 or 20 minutes or so, then your questions will be forwarded on to VTT as well as both of today's speakers, and you'll receive a response within due course. Okay, so let's move into our first question here. So it just asks, what type of applications are there in the oil and gas or in the paint sort of sectors?
Well, there are applications related to rheology modifier, and we have also had some, I think it was UV protection layered, it was a coating on, that was on a paint sector. But the patents are mostly related to the oil drilling fluids and their rheology modifying.
Okay, excellent. Thank you very much. So moving on, this question is mainly for Pia here. It's just asking about your production estimation. It's asking if it is in million tons or in thousands. And they also say that 10 kilotons a year seems like quite a low forecast. Do you agree with that statement?
Yes, I agree with the statement of the low amount when we are talking about the 10,000 tons as an estimate for production of nanofibrillated cellulose. And I want to address that this is not an estimate made by VTT. It is mentioned in the presentation, the report that we have taken these estimates from, and we have used published estimations made by other companies than VTT. And I just wanted to show that the forecasts vary a lot. The variance between the estimate of production of nanofibrillated cellulose in 2025 varied from 10,000 tons per year to 400,000 tons per year, and it's a wide variation. So it shows that there are still some challenges in forecasting the future development of production of nanofibrillated cellulose.
Excellent, thank you very much. Okay, so our next question is, what particular areas of applications are there for CNFs in films, and which properties are valued?
Sorry, I didn't quite hear the question. Could you repeat it? What are the...
Yes, sure. Which are the particular areas of applications within films, and what properties are valued most?
Okay, yes. Well, our understanding is that like the packaging barriers, oxygen barriers, is one of the kind of the highest applications. So not as films as such, CNF films, but embedded in multi-layer structures, transparent films, and then you can also coat CNF films on board. So that's one, oxygen barriers. And then also like a substrate for printed electronics. There you need the smoothness and density. And then also like if you, like we demonstrated, we can make it more water stable, then it's good for the water filtration or membrane filtration applications. And we also have examples how to make membranes thermo-responsive, which is good for filtration also.
Okay, excellent. Thank you very much. So our next question is just asking, what is the name of the tool that you used for the patent review?
It's STN Analyst, and it's downloadable from the net. So you can use the tool, but it's somehow you have to register, and then there are some costs related to when you extract data from the patent landscape.
Okay, thank you very much. Okay, so our next question is, have you had experience with nanocellulose fibers produced from bacteria?
We are focusing to fibrillated grades at VTT, but we have compared performance of CNF grade and bacterial cellulose with our cooperation partners in Imperial College, for instance, in composites as strengthening agents. And we can see that the reinforcement capacity of the materials is very near each other. Of course, there is some differences in chemical composition because we are producing fibrillated grades from commercial pulp. It contains also other components originating from wood than cellulose, but bacterial cellulose is 100% pure cellulose.
Excellent, thank you very much. Okay, so we've still got a lot of questions to go through, so we'll keep cracking on with them. So our next one is, how is dewatering performed in the VTT's HefCel process?
It is a very simple drainage process, and because of the properties of the material produced with the enzymatic process, it is much more quicker than it is normally when we are producing nanocellulose or cellulose nanofibrils by grinding or fluidizing. So it is, and also the production process happens already in higher concentration. The whole process is performed in a concentration of between 20 and 40% of dry material.
Okay, thank you very much. So our next question is, what are the key factors for oil exploration usage?
Oh, excuse me, what was the use?
So the key factors for oil exploration usage.
Oh, okay. Key factors. Well, as I said earlier, the oil is, to my understanding, it's used as a rheology modifier in oil drilling or in a fraction fluid. So the key factors probably are the rheological behavior, how the CNF behaves there, what is it, at what consistency it forms a gel, and how shear thinning the material is. I mean, all these properties have to be optimized. So my answer would be the rheological behavior of the CNF is the key factor.
Perfect, thank you. So our next question, can VTT produce a dry product?
Yes, of course. We can produce a dry product of several grades of CNF, and we can also produce redispersible materials which can be dried. But actually, VTT is not really a producer of CNF. We are actually manufacturing these materials in lab or pilot scale.
Thank you very much. Our next question, what tree species have you used as raw materials? Have willows been among them?
We have used several, naturally, like the Nordic wood species have been our top priority, but we have experienced, like I showed in my slides, over 40 different raw materials, so there are different tree species also, but I don't know by heart whether willow is among them, and I have to check our researchers making the production of CNF to answer this question. So I will come back to this one by email later on.
Okay, excellent. So our next question is also related to the raw materials, and it just asks, how does the raw material affect the production of CNF and its properties? So how would hardwood, softwood, cotton and grass, how would that affect the production and the properties? Well,
we have found that the raw material has a significant influence on the properties. So all the, like the hemicellulose content, lignin content, all these effects, like how it's produced. But that's a very this would require a very long answer, so I would rather come back to this one as also. But there is certainly that the raw material effects of the properties.
Yes, the raw material has certain impact, but it can be kind of decreased with suitable selection of the pre-treatment of the material before defibrillation.
Okay, thank you both. So I'm just going to move on to our next question now, and just ask, what is the expected cost of cellulose nanofibrils, and how does it compare to cellulose nanocrystals?
The expected cost of cellulose nanofibers varies a lot depending on the quality of the material produced. But when we compare to cellulose nanocrystals, the yield in the production of cellulose nanofibril is much higher than in production of cellulose nanocrystals that are produced by acid hydrolysis. So in principle, the cost is usually less than in the production of cellulose nanocrystals.
Okay, thank you very much. Our next question is quite closely related and just ask, how is CNF better than CNC? Is it cost, or is it to do with enhancement of properties, or is it anything else?
I would say that it is dependent on the application needs. Our aim is to produce the material so that the properties of the product are developed according to the needs of the application. So CNC can be in some applications better than CNF and vice versa.
Thank you very much. Our next question is, what is the best option for fibrillation of nanofibers?
What is the best option? This again depends on your application needs. Like I said, for certain applications, like for board making, you can use like refining is a good method to produce those, because you don't need fine structures. But then if you are, for example, manufacturing transparent CNF films, you need a fine structure and very kind of even particle size, then you use some chemical modification, pre-treatment, and then maybe homogenation. So it's very dependent on the application need, and also like the enzymatic HefCel treatment is very good for if you want an all-purpose cellulose nanofibrils. So it's very dependent on the application.
Okay, thank you very much. Our next question is just asking you to give some different applications that there are within cosmetics.
In cosmetics, I would say that one of the straightforward beneficial characteristics of fibrillated nanocellulose is the tendency to change the viscosity or to act as a strong rheology modifier, but it can also act as a carrier of active components in some cosmetic formulation.
Yes, and I would add like we can innovate on several different things also, like the moisture stabilizer, keeping the, like for facial mask, you can have the like ideal moisture in your skin, and then one is trapping oxygen radicals. So these are these kind of innovative solutions for cosmetics that we've been thinking of.
Okay, excellent, thank you. In your new enzyme process, you estimated that the energy cost was €1 per tonne, but what would you say is the total cost, including the enzymes?
We have calculated that that would be like €150, including the chemicals, 150 to €200, including the enzymes and the chemicals. So that would be like the total cost.
Okay, thank you. So our next question is just asking, what is the difference between NFC, MFC, NCC, and CNF, or are they all essentially the same?
No, they are not the same. CNF and NFC are the same, but there is a current standard, or there is a standard proposal that the terminology should be so that CNF or cellulose nanofibrils should be called CNF, and the older version of that was nanofibrillated cellulose, which is the same thing. Then NCC and CNC are cellulose nanocrystals. They are the same. MCC is microcrystalline cellulose, which is not a nanocellulose, but it's larger in shape. And where the other abbreviations, I can't remember anymore, but yeah, they're not the same.
Okay, excellent. Thank you for clarifying that. Okay, so it looks like we've got time for maybe one or two more questions. So our next one is, do you foresee nanocellulose being produced at a pulp mill or at a nanocellulose mill? Are there any synergies in producing these materials at pulp mills?
Yeah, there are different options for that. I mean, I can foresee obviously that the production could be at paper mills or pulp mills. There's certainly a benefit from the synergy. But then for specific applications, why not put a plant for smaller volumes at some other site? So that's entirely possible as well.
Okay, thank you very much. I think I'm going to call it a day there. So there's a lot of questions there we've left unanswered. So as I mentioned earlier, they will all be forwarded on to VTT and today's speakers, and you'll receive a response at a later point. So before I conclude the session today, Pia or Heli, do you have any final thoughts that you wish to leave with the audience?
I would just like to thank the audience for attending our webinar, and this was quite a short general overview of the collected data from published reports combined to our own results and visions of the future of nanofibrillated cellulose. And if you want to continue discussions more in detail, please don't hesitate to contact us. Thank you.
Okay, so that just leaves me to thank Heli and Pia for what was a great presentation, and a big thank you to VTT for sponsoring today's session. To the attendees, today's survey will appear on screen once this broadcast ends, and once again we'd appreciate it if you took the time to fill this out. You'll also receive an email shortly telling you how you can access the on-demand version, as I mentioned earlier, or you can also access this through our website, which is www.business-review-webinars.com. You can also access our site by clicking on the Business Review Webinars logo at the bottom of your screen. Please continue to ask your questions, vote in the polls, and interact with the widgets as the on-demand version remains interactive. We look forward to sharing further webinars with you, so please do keep an eye out on the website just mentioned and follow us on Twitter at BRWebinars for daily updates and join our LinkedIn group, Business Review Webinars. Thank you once again, and I hope you all have a nice day.